Today we're going to be talking about maxima and minima. If a function f is continuous on an interval ab, then because it's continuous, it has a minimum and a maximum. It has to. Now that minimum can be anywhere and the maximum can be anywhere. For example, for this function here, continuous, the maximum is here and the minimum is here. If the function did this and then it went back down here and then like this, the minimum would be here and the maximum would be here. So it goes through a minimum and a maximum. And in today's lecture, we're going to figure out how to find these minimum and maximum, these minima and maxima. Extrema means minima or maxima, and this is the plural for minimum or maximum. So this would be maximum. If it's one, it's a maximum. If it's more than one, then it's maximum. And this is minimum. So we're going to figure out how to find these max and min. Okay. A maximum or a minimum is a point that's special. And in the last video, we talked about critical points and critical numbers. So this has to be a critical point or a critical number. A critical number is a point at which the derivative is 0 or it's undefined. For example, it could be a point like this. That's a critical point. Or this one. This one is a minimum. This is like a regular, smooth minimum. This one is not smooth. The function is not differentiable at this point, but still it's a minimum. So we're going to learn how to find these. And we're going to start with this example. Example 201. F of x equals x squared minus 8x minus 19. The first thing we need to do is find the derivative of this function. The derivative f prime of x is 2x minus 8. Then set it equal to 0 because we're looking for a critical number. Okay, when you set this equal to 0, you end up with 2x equals 8, x equals 4. So x equals 4 is a special point. We need to figure out what kind of special point it is. So it could be a minimum, it could be a maximum, it could be neither. And what we need to do, there is a test called the second derivative test. We're going to apply it to this x equals 4 to figure out if it's a min or a maximum. The second derivative of this function here is f double prime of x is, here's the derivative. The derivative of this derivative is 2. If the derivative is positive, then the point is a minimum. If the derivative is negative, the point is a maximum. So this point here, 4, f of 4 is I'm going to leave some space here and I'm going to write minimum. Okay, it's called a relative minimum or a local minimum. So I use the word relative or local. You don't have to write both, okay? Minimum. So when the derivative is 0 and the second derivative is positive, the point is a minimum. It's a relative or local minimum, which means if we graphed this function here, the graph would have looked like this. It would have had a minimum, a lowest point, and that would be x equals 4. F of 4, if you have to find f of 4, you plug it back into the original equation, substitute 4 in here and in here, and that gives you what f of 4 is. But at this point, we don't have to do it. Let's do another example. This function here. We're looking to see what the min and max are for this function, if any. So, first thing, find the derivative. F prime of x equals 6x squared minus 2 times 3, which is 6x minus 12. And what do we do with this derivative? We set it equal to 0. Okay, each one of these numbers is divisible by 6. So let's divide the entire equation by 6. Divide this side by 6 and this side by 6. So that gives you x squared minus x minus 2 equals 0 over 6 is 0. We can solve this by factoring. This will be x minus 2 x plus 1 equals 0. The first factor gives us x minus 2 equals 0. Second factor is x plus 1 equals 0. So from here we get x equals 2, and from here we get x equals minus 1. So these are special points. These are critical numbers. We need to figure out what kind of critical numbers they are by figuring out the second derivative. Okay, the first derivative was 6x squared minus 6x minus 12. The second derivative is going to be f double prime of x equals, differentiate this before you do anything to it. Don't divide by 6. So it'll be 12x minus 6. 12x minus 6. And we need to figure out what's the value of the second derivative when x equals 2. So for x equals 2, okay, x equals 2, f double prime of 2 is 12 times 2 minus 6. That's a positive number. And then when x equals negative 1, the second derivative at negative 1, put negative 1 in there, 12 times negative 1 minus 6. That's a negative. We don't care what the number is, we only care about the sign, and we don't want it to be 0. 0 is another special point which we'll cover in a different video. So x equals 2, f of 2 is a relative m. I'll fill this in a minute. X equals negative 1, f of negative 1 is a relative m, and I'll fill this in a minute also. Okay, the second derivative was positive here, so that makes this point a minimum. The second derivative for minus 1 was negative, so that makes this point a maximum. So 2f of 2 is the relative minimum, minus 1 f of minus 1 is the relative maximum.